Naming of hydrocarbons. So we want to name different hydrocarbons as we are going to continue looking at these questions. Name each of the following compounds. Compound number 1, we have been given this compound. So for you to give the correct name of this compound, first you have to identify the longest continuous carbon chain to determine the name of the parent. Whether it is this one is an alkene. We are going to find out whether it is an alkene or an alkene or an alkyne. So what you do first, it is important to write open the structural formula for this first, and then identify the longest continuous carbon by counting the number of carbons that contain the longest continuous carbon chain. So 1, 2, 3, 4. 1, 2, 3, 4. So both with this direction and that direction has 4 carbon atoms. Therefore, the parent name we can get that it is butane. So it can be butane, butene, or butane. But the parent name is as 4 carbon atoms. Therefore, we can call it butane for now. So let us write this structural formula for this. That is carbon 1, 2, 3, 4, 5. 5 or 4? 3, 4. There are 4. And then here we have hydrogen. This carbon we have CH3, and then we have 1 hydrogen. Here we have 1 hydrogen and then 1 bromine, and then here we have H. So as we can see, this compound, every carbon atom is surrounded with a single covalent bond. Therefore, is an alkane. So if it is an alkane, therefore it is the parent name is butane. Now, the next thing, we are going to number this longest carbon chain in such a way that we give the branches, this one we call the substituent, the branches, we give them the smallest numbering. Therefore, you see this one, even if I 1, 2, I will get the first branch. This one will be the third. Even if I stand 1, 2, so this one I will number from anywhere. So I will number 1, 2, 3, 4. I have my numbering like that. So when we are going to now that we have the parent name, now we can give the substituent groups the names. When the one compound like this contain this one is bromine, we say bromo. We start the word, the halogen as bromo. If it is chlorine, we use chloro. If it is bromine, fluorine, we use fluoro. Another one is what? Bromine, chloro, and then we have the methyl group. A methyl group is an alkane which has been in which 1 hydrogen has been removed. So now you can see we have a methyl group, and then we have an alkane. Therefore, this halogen is found in carbon number 2. Therefore, we say 2. Because it is bromine, we write bromo. And then dash 3 methyl. And then the parent name now is butane. So 2 bromo, 3 methyl butane, and that is the name for this compound. If we have more than 2 halogens here, we will ensure that you write alphabetically. You follow the alphabetical order. Even if you look at this, we start with B, bromo, and then methyl. So let me give another compound which contains more than 2 halogens, and then we will see how to So we have this one, we have C, 1, 2, 3, 4, 5. We have hydrogen, hydrogen, hydrogen. We have here bromine. We have hydrogen. We have H3. We have another bromine here. We have chlorine, hydrogen, 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 hydrogen. So this is an alkane because you can see each carbon is surrounded with a covalent bond, a single covalent bond, therefore it is an alkane automatically. So for rule number 1, count the number of carbon atoms that are contained in the longest carbon continuous carbon chain. So 1, 2, 3, 4, 5, 6. So we have 6. That one is hexane. So the parent name is hexane. Having done that, then you number the number of carbon atoms, number the longest chain from the end that is near to the branching. So the branches are here, bromine, bromine, this one. So if we start 1, 2, 3, we find the first branch at carbon number 3. If we start here 1, 2, we find that the first branch we find it at carbon number 2. Therefore it is important we start numbering here 1, 2, 3, 4, 5, 6. Now since we know the parent name is hexane, no, we give this one. Now remember, when we have more than 2 halogens of the same, we use these terms. Di means 2. Like this, we have bromo, 2 of them. We are going to say dibromo. If there are 3, we use tri. If there are 2, di. If there are 3, tri. If there are 4, 3. If there are 4, we use tetra. So let us now give the correct name for this organic compound. We have said the hexane. So carbon number 2, we have bromine. Carbon number 3, we have bromine. And then we have chlorine. So this one must come alphabetically. So between dibromo and chloro and methyl, which one comes first in the alphabetical order? So you saw A, B, C, D, E like that. So C, chloro, will come before di. Therefore chloro is supposed to come first. So that's why we say now the name as 4-chloro. 4-chloro. And then the bromo, there are 2 of them. So we have 2, 3, and then dibromo. Then we have the methyl group on carbon number 3, and then 3 methyl. Now the parent name hexane. So this is the name for that organic compound. So when we have more than 2 halogens or 2 methyl groups or 2 chlorides in the same compound, we use di to mean 2. So dibromo, dichloro, dimethyl, difluoro, like that. If there are 4, we say tetrachloro, tetrabromo, tetrafluoro, like that. So we use that one. Organic number 3. Draw the structural formula for each of the following compounds. 2-methylbutane and then 2,2,4-trichloropentane. So from here you can see this one is these are alkanes because it is pentane, and the parent name is butane, therefore meaning that it has 4 carbon atoms. That's where we begin. 1, 2, 3, 4 carbon atoms. And now when you're drawing, you just number from anywhere, from this side to the left or this one to the right. So let me start here. 1, 2, 3, 4. So my carbon number 2 is here. So then carbon number 2, I have methyl group. Methyl group is CH3. And then that's also the rest you fill with hydrogen atoms. and this one is 2-methylbutane. Next one is 2,2,4-trichloropentane. So we start from the parent name. The parent name is pentane. Pentane means that 5 carbon atoms. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can start numbering from here. 1, 2, 3, 4, 5. It's not a must I start numbering from this one. When you are drawing, you are free to start numbering from either on the left or to right. Now, carbon number 2, we have chlorine. Carbon is same number 2, we have another chlorine. That's why when we 2 means the group, the branch is in the same carbon. 2, that means it is in the same carbon. And then 1, 2, 3, 4, and the carbon number 4, we have another chloride. So that is all. Now the rest you fill with hydrogen atoms to make it complete. And this one is 2,2,4-trichloro. Tri means that there are 3 chloride atoms in this structure. Now we have another 2 compounds here. Compound number 2, we have CH. So we can see the number of carbon atoms is 1, 2, 3, 4, 5. That one is fine. 5 carbon atoms. So the next thing, we want to give it a name. So once we have 5 carbon atoms, now what we don't know is that whether it is a pentane, pentene, or a pentyne. You cannot know that by just looking at it. You have to draw the open structure for this. So let us draw 5 carbon atoms. 1, 2, 3, 4, 5. So hydrogen here we have 3. Here we have 2, 1. We have another one here. Here we have 2. Here we have 2. Here we have another one, another one, and another one. So once we have done that, we know that each carbon must be surrounded with 4 covalent bonds. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. So this one is surrounded with only 3. So that one tells you that you should add a covalent bond here. Now 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and it is complete. Therefore, this tells you that this compound is an alkene. Double bond is an alkene. Now we can give it the name. 1, 2, 3, 4. The next thing is where the function. So the double bond is the functional group. Now we want to know where is our functional group. You give the functional group the number. And you're ensuring that you give it the smallest number. So if I start numbering from this, the number of carbon atoms from this side to the left, 1, 2, 3, I will give the double bond 3. It is first you attach it to carbon number. But if I start from this side, 1, 2, so I will find my double bond on carbon number 2. Therefore, the correct numbering is to this side, to the right. 1, 2, 3, 4, 5, ensuring that you give the functional group the smallest number possible. So now it is a pentene and it is pent. Where the double bond is carbon number 2, on carbon number 2, that is 2 pentene. So pent 2 in. So this one, 1, 2, 3. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So 5. And then let us put the hydrogens where they are supposed to be. 1. Here there is no hydrogen. There is no hydrogen. We are here. The fourth one, hydrogen. Another one and another one. So like we said, you must ensure that each carbon atom is surrounded with 4 covalent bonds. We know the parent name is 1, 2, 3, 4, 5. Is it a pentane? pentene or pentyne. So after doing the writing the structural formula, now you can see this one is 4 covalent bonds, 4 covalent bonds. This one has 4 covalent bonds, but this one has 1, 2, and this one has 1, 2. That means you have to put add another bond here. When you add 1, 2, 3, not yet. You add another one. 1, 2, 3, 4. 1, 2, 3, 4. So that means each carbon atom is surrounded with 4 covalent bonds. Therefore, and now you see the functional group here is triple bond. It means it is an alkyne. It is an alkyne. Therefore, now let us give a number. We number the number of carbon atoms in such a way that we give the functional group the smallest number possible. So if we start from here 1, 2, 3, we find the triple bond at carbon number 3. Before we find, so before we reach the triple bond, we are at carbon number 1, 2, 3. But let us start this side. 1, 2. We will reach carbon number 2 and then the triple bond. Therefore, the correct numbering is on the right side. This one will give the carbon number 3. This one will give carbon number 2. Therefore, 1, 2, 3, 4, 5. So it means that our carbon, our triple bond functional group triple bond is on carbon number 2. Therefore, the correct naming now is 1, 2, 3, 4, 5. The parent is pentyne. But now it is pentyne, we must give the functional group the position where it is. So it is on carbon number 2. So we write pent dash 2, carbon number 2, and then yne. And that's how we name the compounds. So, and that's how we identify whether it is an alkane, an alkene, or an alkyne. You have to draw the structural formula and ensure that each carbon atom is surrounded with 4 covalent bonds. If the number of covalent bonds are not enough, you are the one to see at which point you are supposed to fill up with the covalent bond. Draw the structural formula of the following organic compounds: 2,2-dichloro, pent1-ene. Ene tells us that it is an alkene. It is an alkene. It's an alkene, yes. And the functional group is on carbon number 1. That's what it means. So, and the parent name is pentene, 5 carbon atoms. So 1, 2, 3, 4, 5. That is pentene, 5 carbon atoms. And the double bond, because ene means double bond, so it is on carbon number 1. So this is number 1, or you can start here carbon number 1. It doesn't matter. So here we have a double bond 1. So we have finished the parent name. We have identified that it is an alkene. Now we go to this one on carbon. So if this is number 1, number 2, 3, 4, 5. On carbon number 2, actually this is supposed to be number 3. 3. On carbon number 3, there is a dichloro. So there is 2 chloride. 1, 2, 3. Here there is chloro. Up there is chloro. Because di means 2, so there are 2 of them. And then we are finished. So the remaining you fill with hydrogen ions. You fill the remaining spaces or gaps using covalent hydrogen ions. There like that. You fill with hydrogen ions, ensuring that each carbon is surrounded with 4 covalent bonds. So here 1, 1. Here we will put 1. We'll have 1, 2, 3, 4, and then here 1. Here 1. 1, 2, 3, 4, 1, 2, 3. So you always ensure that each carbon atom is surrounded with 4 covalent bonds. We have another one here. We start here. It is an alkene in. Therefore, it is a double bond. The double bond is on carbon number 2. Very important. 1, 2, 3. Butane is the parent name. But it means butene. It means 4 carbon atoms. 1, 2, 3, 4. The double bond is on carbon number 2. So here we can start from here or here because it is the same. So 1, 2, and 3, and 4. So here we have the, and then we have bromo on carbon number 3. So 1, 2, 3, we have bromine. So fill the rest with hydrogen atoms. The rest with hydrogen atoms, ensuring that each carbon is surrounded with 4 covalent bonds. 1, 2, 3, 4. 1, 2, 3. So 1 is missing here, hydrogen. I'm missing here. 1, 2, 3, 4. It's okay. 1. So here 1. Another one. Another one. And this is what we call 3-bromobutene. The next one, the parent name is ine. Ine implies that it is an alkyne. Triple bond, that's what it means. And then the parent is X. It means hexyne is 6 carbon atoms. So 1, 2, 3, 4, 5, and then 6. 1, 2, 3, 4, 5, 6. But the functional group is on carbon number 1. So this is carbon number 1. So or this one, N. 1, 2, 1, 2, 3. Hexyne, 3 double bonds, triple bond. Carbon number 1. So we have it there. And then so 1, 2, 3, 4, 5, 6. So on carbon number 2, we cannot have number 2. I think there's something wrong because this one is already full. So on carbon number 3, 3 fluoro 2, 3 fluoro 4. Methyl X, that's okay. 3 fluoro 4 methyl X, that one will work because of the covalent bonds. Each carbon must be surrounded with 4 covalent bonds. So if 1, 2, 3, 4, we cannot add anything else here because already it is surrounded with 4 covalent bonds. So here now we put only 1 hydrogen. Here we don't put anything. Here we put the fluoro, capital F, and then here hydrogen. 1, 2, 3, 4. On carbon number 4, we have a methyl group, CH3. It's called methyl. And then here hydrogen. Here we will put 1 hydrogen and another hydrogen. Here we will have hydrogen, hydrogen, and hydrogen. And this one now is 3 fluoro 4 methyl X 1 ine. Ine tells us is a triple bond. It is an alkyne. 1 tells us that the functional group, the triple bond is on carbon number 1. X gives us the parent name, the number of carbon atoms. There are 6 of them, and these are the substituent groups. Now, what could be the name of this organic compound here? Looking at this compound at a glance, it is very difficult for you to give it a name, and at least you can only see, the only thing you can see is the number of carbon. 1, 2, 3, 4, 5. So meaning it can be an alkane, an alkene, or an alkyne. So it can be pentane, pentene, or pentyne. But looking at that, you cannot say actually it is an alkane or an alkyne, or you cannot. So then the most important thing is to draw the structure for that. So open the structure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then put the hydrogens that are present on carbon number 1, or let me call it 1 from this side. We have 2 of them. On this 2 we have 1 hydrogen. Here we have 1 hydrogen. Here we have bromine, and then here we have 3 of them. Right? So the next thing is to ensure that each carbon is surrounded with 4 covalent bond. So already this carbon is surrounded with 1, 2, 3, 4. So there's nothing I can add here, and there's no need of doing that. But look at this 1, 2, 3. So 1, 2, 3, this one. So I can add a double bond here, another bond here. So we have a double. So now 1, 2, 3, 4. 1, 2, 3, 4. Fine. Look at this 1, 2, 3. 1, 2, 3. So I cannot add anything here because 1, 2, 3, 4 it is okay. So it is something I have to do here. 1, 2, 3, 4. 1, 2, 3, 4. Now this compound is fine. So by so doing, I now know this one is an alkene. Why? Double bond. Now let me go ahead and give it a name. I will give number this carbon, this hydrocarbon, such that I will give the functional group the smallest number. So I will start here. 1, 2, 3, 4, 5. Another thing you can see is that we have two covariant functional groups here. Two functional groups. I am going to show you how to write them down. So first, on carbon number 4, we have bromide ions. So we will start there. 4 bromo, right? And then we have 1, 2, 3, 4, 5. So it is pent on carbon number 1, comma, on carbon number 3, we have two functional groups, which is an alkene. Therefore we call di because of 2, and then it is an ene, diene. So 4 bromo pent 1, 2, 3, that's diene, because if it was only one bond we could say 1 ene. So because there are 2 we call diene, because there are 2 of them. So this is the correct naming of this compound here. 4 bromo pent 1, 3 diene, because of the 2 functional groups. The next thing we will look at is about the chemical properties of hydrocarbons. Chemical properties of hydrocarbons. We were doing naming. I think that one is helpful now.